Welcome to a new episode of Automotive, Benefits Beyond the Bond, where we dive into the world of Sika's innovative damping technologies, exploring how these cutting-edge components are developed, produced, and tested at facilities around the globe. Our journey begins in Worms, Germany, home to Sika's Acoustic Center, where Bernd, a seasoned automotive engineer, leads the charge in advancing acoustic comfort for passenger vehicles. Alongside his colleague Oliver, who has been the team leader at the center since 2019, they are at the forefront of creating quieter, more comfortable rides. Acoustic comfort is a key factor in customer buying decisions, especially as electric and, in the future, autonomous vehicles dominate the roadways.
Oliver, can you please explain which noise sources are affecting the interior noise of a vehicle that affect customer comfort?
Acoustic comfort, as you said, is an important issue and factor for our customers in taking buying decision. And acoustic comfort is especially important for electric vehicles, but also in the future for autonomous vehicles as well. And while riding on the road, the vehicle is affected by many different noise sources at the same time. This could be a powertrain noise coming from electric motor or combustion engine. This is the road-tire interaction. As the road noise, we have wind noise at higher speeds, and we have raindrop excitation as the weather phenomena, for example. And all of these noise sources, they are affecting or they are inducing structural vibrations in the car body, which are transmitted all over the vehicle and then radiated as the airborne noise inside of the passenger compartment. And this is how actually acoustic comfort is reduced by these vibrations. Mm-hmm. And Bernd, could you please explain to us how Sika is solving these issues in the vehicle?
Yes, Oliver. In order to mitigate these vibrations, meaning reducing the interior noise, we need to apply highly effective damping materials.
But which damping technologies are available on the market today?
Basically, we are talking about three different technologies. One is a bulk material, a sprayed-on damper. The other one is a single-layer solid damper technology. And the third one is a constraint layer damping technology consisting of an acoustic layer and a constraining aluminum layer.
But what's the difference between all of these technologies in terms of performance?
The single layer technologies come with a medium cost level, at a medium acoustic performance level, at higher weight requirements and higher space requirements compared to the constraint layer technologies. These constraint layer technologies are a little bit higher in cost, but they come with a way higher acoustic performance at lower weights and lower space needed.
Let's shift gears and head to our material development lab in Frankfurt, where our innovative products are produced. Frederick, please walk us through the production process.
As Bernd already told you, these are our constraint layer dampers, which are the best-in-class solution for automotive damping. These materials consist of a butyl mass and a constant top layer, which is the aluminum. We are now here in the material development lab because we are here developing these butyl masses.
As you obviously know, this is our standard device for mixing and preparing lab batches. Unfortunately, my last lab batch was not optimal, meaning that the viscosity was too low and the acoustic performance was shifted to lower temperatures, and we don't want that. So to counter that, I have added some different thixotropy agents to increase viscosity and thermoplastic behavior, and I have added some higher melting resins in hopes of moving the peak to the right temperatures range. So therefore I will test heat sliding and acoustic Oberst performance directly after finishing this batch.
Okay, so you are concentrating on the most important properties, which is the acoustic performance and the heat resistance. These are the important properties for our materials because the acoustic is what we sell, and this is measured by Oberst test method, which is an easy and fast way to determine the acoustic properties of a product and to compare it with an old generation or an old mix. Furthermore, we need this heat resistance to be able to apply our parts in the body shop process, because afterward there are many ovens at the OEM production process and the material has to stay in place. So Marco, let's see the results. Oh, time is over. Here you see the old formulation, which has a sliding of about 5 millimeters. And if you compare it to the new one, there's no sliding at all. So this is a heat-resistant material which is completely in accordance to our customer specifications.
Sika's mission is to provide clients with highly efficient acoustic solutions. It's not just about delivering top-tier products, it's also about integrating well-engineered concepts into the vehicles. Oliver, could you take us through how the Acoustic Center works closely with customers to help them achieve this goal?
Yes, sure. In order to support our customers and our research and development technology centers, Sika is operating various acoustic centers around the world. We are here in Worms in Germany right now, in one of these acoustic centers, which are offering various state-of-the-art acoustic testing capabilities which can be used by our customers in order to derive proper optimized damping packages in all stages of the product development. The evaluation of acoustic materials and their impact on acoustic comfort is conducted on 3 different stages depending on the product development process of our customer. First level of evaluation is of course the material level, where we are closely looking on our damping material in detail, evaluating loss factor performance, so the actual damping performance of this material at different temperatures, different frequencies, which is also of course important in terms of new mobility applications such as e-vehicles. The component level testing is implemented if we are looking on the proper application of Sika products in certain scenarios in the car, in certain components, for example in car doors. And not only acoustics in the car door is important, where we are deriving optimal placement of damping patches there, but also the haptic quality is important. And this haptic quality can be improved by our hybrid solutions with improved stiffness functionality. And of course, last but not least, in order to implement the optimized damping package in the entire vehicle, not only components, but the entire car body needs to be considered. And for that purpose, we can use prototype or production state car bodies in our lab. We are introducing predefined structural excitations into the car body, and we are evaluating with the laser vibrometry testing method all of the relevant vibrating surfaces and optimizing damping layout on them. And at the end of this development process, customer receives an optimized damping package in terms of acoustic performance, lightweight efficiency, costs, and of course production capabilities.
Sika has developed and patented a vacuum application technology. It uses vacuum to expand the membrane and thus pressing the Sika damp onto the substrate. For example, a car body panel. Advantages of using this technology includes repeatability, stable cycle time, no risk to mark the A surface, no operator influence, and minimal air pockets. To validate the concept and to perform initial line trials at our customers, we can develop a tailor-made lightweight applicator using 3D printing and within a short period of time. This technology can be implemented in the production with various levels of automation. It can also be semi-automatic with an handheld applicator. In this case, we add Pokayoka feature for an error-free and repeatable application. An on-site demonstration of this technology is also possible with an handheld applicator.
Our goal is to assist customers in conducting proof-of-concept testing and ensure the seamless integration of automated solutions into their operations. To support this, Sika has established a state-of-the-art technical center dedicated to developing and validating cutting-edge automation solutions specifically for its parts business. Leila Rio, Sika's sustainability manager, shares the opportunities for integrating sustainability into operational practices.
Here in Frankfurt, we deployed sustainability practices for operational activities. On top of using green electricity, we also now recycle scraps from our production. Indeed, some customer-specific parts are stamped on an aluminum butyl composite. Beforehand, the pinch grid was just processed as normal waste. What we do now, using liquid nitrogen, is actually to separate the butyl, which can then be reused in our own manufacturing process, and the aluminum that can then be sold to the industry as a raw material.
Thank you for joining us today as we explored how Sika's commitment to innovation and excellence shapes the future of automotive comfort and performance. With a global presence and cutting-edge technology, we're proud to support OEMs and manufacturers as they create more efficient and sustainable cars for the road ahead. We hope you enjoyed this journey and look forward to having you with us for the next episode as we uncover more exciting advancements in the automotive landscape.